So here we're trying to find the center of mass of a region which is parabolic. So think of a symmetric parabolic region, and of course the center of mass will be closer to the x-axis than 1. So the answer to this question better be less than 1/2. If you get something more than 1/2, then you definitely made a mistake, because as you can see, you have more stuff down here than on top, right? And as I explained before, the center of mass, because this is symmetric with respect to the y-axis, the center of mass, the x-coordinate of the center of mass will be 0. So that doesn't need to be calculated. We only need to figure out the y-coordinate of the center of mass, and to do that, we have to do this calculation. This was the formula I put in. And my explanation was simply, this is nothing else than doing weighted average. Yeah. You add all the y values with certain weight, okay, and you divide it by the weight themselves. Okay, that's the way to understand this formula. It's a weighted average. And first of all, this denominator is somewhat simple to calculate. It's just you take this integral 1 minus x squared, because it's the area under the curve. It's just simply this integral from -1 to 1. And furthermore, as you can see, because of the symmetry, you can just double this, the integral from 0 to 1, which is a lot easier. And that integral is x minus 1/3 x cubed. You're plugging in 1 and 0. And if you plug in 1, you get 1 minus 1/3, which is 2/3. 2/3 times 2 is 4/3. So that's the denominator. Let's work on the numerator. Numerator, we have to integrate with care. We do need a double integral, and the way we're going to integrate it is by trying to paint this upwards. That's kind of the natural choice, because the bottom bound is y equal to 0, top bound is 1 minus x squared. If you try to paint rightwards, then you have to solve this for x, and you get much harder integral to do. So it's easier to go this way. So we're going to paint it upwards. Let's see if you know how to do this. Y. Okay, first of all, if you're painting upwards, is it dx dy or dy dx? Dy dx. And if you paint upwards, what's the bottom bound? 0. Y equals to 0, right? Y equals to 0 is the bottom bound. What's the top bound? Y equals 1 minus x squared. Y equals 1 minus x squared. So that's what you put over here. Y equals to 1 minus x squared. Okay, and once you integrate out the y, you get things that are populated in the x-axis, right? The x values go from where to where?
-1 to 1.
-1 to 1. So that's the numerator. This is what we're trying to integrate, which gives you -1 to 1, 1/2 y squared, you plug in 1 minus x squared and 0, and then dx. And that gives you 1/2 1 minus x squared squared dx from -1 to 1. Okay, it would be nice if we could do the calculation of this without foiling this out, but unfortunately there isn't any. So you really need to do this calculation somewhere. 1 minus x squared squared is 1 minus x squared times 1 minus x squared. So you multiply this as 1, -x squared, -x squared, plus x to the 4th. If you organize this well, you're going to end up with 1/2 -1 to 1 of x to the 4th minus 2x squared plus 1 dx. Now notice that x to the 4th, that's an even power, x squared, that's an even power. Constants can be thought as x to the 0th power. So all exponents are even numbers. Those functions are called even functions. Their graphs have symmetry on the left and right side. And that helps you with calculation because you don't have to integrate from -1 to 1. You can just integrate from 0 to 1 and double this result to get the full integral. So that's what we're going to do. We're going to double this integral, which twice of 1/2 will cancel. So the 1/2 cancels out. And the interval now is from not from -1 to 1, but 0 to 1. Whose integral is 1/5 x to the 5th minus 2/3 x to the 3rd plus x, and you're plugging in 1 and 0, whose value is 1/5 minus 2/3 plus 1, which is 1/5. 1 minus 2/3 is 1/3, right? So if you do 5 times 3, that's 15. So you multiply 3 top and bottom, 5 top and bottom, so you get 3 plus 5, which is 8 over 15. Okay, so we got the numerator, we got the denominator, now we can plug it in here, and we get 8 over 15 divided by 4 over 3. 8 over 15, well, division by a fraction is multiplication by its reciprocal, so we're going to flip this top upside down. So it's 3 over 4, which you can cancel furthermore, and you get 2/5. And that makes perfect sense. As I said, the center of mass should be lower than 1/2, right? 2/5 is 0.4, so it's less than 0.5, which is 1/2, right? So the result is saying that the center of mass is 2/5 of the height. And now you just have to have a little bit more geometric argument to get something more meaningful. Let's say you have, so let me just erase this part and just show this a little bit. So let's say you have a parabolic shape so that you have this length as h and this length as b. And what's the center of mass? Well, you have to make some argument saying that, well, this length b is not really going to change the center of mass because if you increase b, it increases this proportionally. Like if you double this b, all of this increase proportionally, so the center of mass is not going to be changed. So you can kind of make an argument that really the only thing that changes the center of mass is this height. And what we've shown is that if this height is 1, 2/5 is the center of mass. Therefore, if the height is h, the center of mass will be at
2/5
2/5 of
h.
h. Right. So 2/5 of h, this portion right here, is where the center of mass is located. Okay, and this is another result that you'll be using in your engineering statics course or dynamics course, because in physics, one of the revolutions that Newton brought about in physics, I mean, he made everything, but he was able to explain that the motion of an object can be really thought as a single point-like object, which is at its center of mass. So if you had, say, 1 pound of this object, you can think of that 1 pound to be only located at this center of mass, and the movement can be just completely explained by the movement of that point. Okay. Of course, if it's rotating, that's another matter. That should be internal calculation that should be thought separately. Okay. But that's how you do the center of mass.